Welcome everybody to You Did What with the JavaScript API. And in case you were wondering, that is the correct pronunciation. So after when you are telling your colleagues what session you were at, I expect you to say, you did what with the JavaScript API, exactly like that. My name's Michael Kovner. I'm a sales consultant for OEM, so I primarily work with OEM partners for Tableau. That's people, companies, software companies that integrate Tableau content with their applications and then sell that packaged software. So all day, every day, I'm talking about JavaScript API, REST API, and all of those integration subjects. With me today, I have Russell Christopher, who was my manager as a sales consulting manager last year. 1 year was enough, I guess, of that, because he ran as far away as possible to Singapore, where he is now the SC manager. And we're really excited to have Tomas Foldy, who is, I asked him what his title was, and he couldn't tell me, so I wrote Tableau Hacker Extraordinaire, really doing all the craziest stuff with Tableau server there is, and he works for starschema.net. So we have a pretty simple agenda here today. We're going to show you something cool using the JavaScript API. We're going to crack open the code and show you how we did it. And then we're going to repeat and repeat and repeat. And these demos are many of them are going to be kind of wacky. In fact, most of them you would never say, oh, I'm going to go do that demo back at home. So why are we showing you these wacky demos that make you say, you did what? The reason is because they're creative uses of the JavaScript API. And this is the third year we've done it, and we've found that people come back to us and say, you know, obviously I'm not going to do what you did, but I learned what are the main functions of the JavaScript API? What can it do? And what are some of the deeper functions of the JavaScript API? And how can you combine all those into a single concept? And people take those ideas, synthesize them, get the creative juices flowing, and learn how to use that back home with their applications or with their deployments of Tableau server. And one quick note about the agenda. We have, I don't know how many this is, 400 technical people. Anytime you get above 30 technical people in the room, mid-session Q&A can derail the conversation. So we're going to hopefully have 5 to 10 minutes for Q&A at the end of the session, so we'll hold all questions till then. All right, without further ado, 3 slides of PowerPoint and we're out. Oh, yeah, you're going first. Yeah. Right, so this is Russell. Again, he's going to show you some cool stuff, and then I'll come back and show you some other cool stuff.
You see, you already derailed the whole presentation. I had another slide here. Remember we had the whole joke slide that we thought was going to be so funny?
Oh, yeah.
Yeah, and you just totally messed it up. I can't believe it.
Still there. I didn't delete it.
I know, but look at this thing. See, this is why I went to Singapore. All right, here we go. Okay, so, yes, that's right. So I'm Russell Christopher. You know that already. Hello. I'm a manager. I am semi-technical, but I am not a programmer. I'm not a developer. How many developers are in the room? Oh, crap. Okay, so you are going to hate my code. I am not a programmer. The way I program is I see something, I copy it, I paste it, and then if it compiles, yeah. So part of this is an exercise in letting the people who are not programmers know that you can still do some really interesting stuff with the API with my level of technical skills. And as a proof point, Tomas, who's coming after us, one of our Zen masters, actually had the following to say about my technical skills here. Russell has nothing to do with programming. His code is ugly. Sorry, mate, but pushing a project where the main class in form1.cs is just sick. Now, I don't actually even know what that means, but that will kind of give you an idea of what's coming up. So let me get out of here, and we'll go ahead and get started. So, all right. Let's get out, and here, and away we go. So I have about 6 things to show you. Most of them are pretty basic. I'm kind of the warm-up guy. I'm going to start off with just viewing vizzes. I want a more basic way to view a visualization. This is just using a lightbox control, a jQuery lightbox control. I don't want to see every single viz. I don't want to go into the portal. Just show me some highlight stuff. If I had this on a mobile device, I could swipe through it with gestures. I can't right now since I'm on a real machine. But you can see I can kind of play around with what's here. These are all completely interactive, of course. So I can kind of take this and do whatever I want to and play around with the viz. So this is pretty simple, but it's a nice way to just sort of highlight the visualization versus the portal and everything else that wraps it. So let's move along. Here's something a little bit more complex. This uses a jQuery add-in called Mixup. And again, I just have thumbnails here. I might sort them in various ways, ascending, descending, random. You'll see that most of these vizzes have little dog ears, blue, green, etc. You know, these might be for you, I don't know, business groups or projects. I can filter. So if I only want to see certain types, I can do that or show none of them, etc. Again, when I see something that I want, I can click on that. We're going to use the same lightbox control. This is one of my favorite vizzes of all time. I just love this thing. This is a DataBlick creation for those of you who aren't familiar with them. Very cool stuff. So this next one I kind of like a lot. It's called the Tableau Public Never-Ending Dashboard, and theoretically it never ends. You're not actually looking at vizzes right now. You're just looking at images. So this is kind of cool for two reasons. For a user is just going to kind of come in here, and they get this kind of nice flow experience. They just kind of see what's here, and then when they find something that looks interesting, like this, they click on it. We're replacing the image with the viz, and now the user can come in and interact with it and filter and sort and do all the fun stuff that Tableau lets you do. And then you continue on. So that's kind of the good news. The good news for an administrator is that you don't have users pounding your server to death while they are viewing vizzes. You just show them sort of previews, they find what they like, they click on it, life goes on. So I'm going to crack open the code on this one, just kind of give you an idea of how it works. Let's see, come on now. There we go. So this is very, very basic stuff. And in fact, it looks like I need to refresh this guy to get what I want. So essentially, I'm just driving this out of an array, right? We have an array which is pointing to each of the Tableau public URLs where the vizzes actually live. Here's where we're looking at the image, the height of each image, the width of each image. So pretty simple. I chose to do this and just hard code it. You guys who are better at this sort of stuff than I am could write a little service that's constantly scraping public or your server and generating the images and making this a little bit more dynamic. But all it is, it's an array with information. Not that exciting, right? In terms of actually making the page, it's about as simple can get. We have on page load a page load function. Imagine that. And we are just looping through that array I already showed you. All we're doing here is building out a list item. So we have an unordered list, and just like when you did your first HTML and did 3 bullets and you were very proud of yourself, that's all we're doing. We're appending list items which include the height and the width and the actual information about the image that we are going to insert just over and over again. And when someone clicks on one of these guys, we do something interesting. So we'll look at interesting. Now, how many of you have used the JavaScript API already? Just quick show of hands. Okay, so we expected a fair amount of knowledge here. I'm going to go over one of the more basic things right now, but I'd invite you to use the wonderful documentation and spend a little bit more time with this yourself. Essentially, once someone clicks, we're going to do a couple of things, and then we just start rendering. First of all, we remove the image. We go into the list item, we whack the image. We use jQuery, and we go in afterwards, and we append a div. This div is where we will be inserting, I guess you could say, or instantiating the visualization. After that, we need to know where that div is. So we have a little variable that is pointing to the div that we just created. We also have another variable which is pointing to the URL of the visualization that we are about to render. That was the first thing that you saw in the array, the pointers to Tableau Public. We have some options, like do I want to show tabs? Do I want to show toolbars, height, width, etc., etc.? We feed those options in. We feed the workbook URL to Tableau Public, and we tell our little method here where the viz is, or excuse me, the div, and then we instantiate a brand new viz, and we're done. So we do that as many times as we need to, as people click on the visualizations and come in and play. So let's move along. Actually, let's do this, because I always kind of like that. It's fun. One more time. Come on. Yeah. I just love that. All right. So auto-refreshing. Okay. If you ever wanted to know the exact date and time on Tableau Public, and you're very worried about that, here you go. All right. All this does is it's a viz, it's refreshing over and over again. You all are going to use this in a scenario where you have a big display in the office. You probably have some sort of operational data, and you want to sort of update the viz automatically. This is about as simple as it can get. Another little jQuery add-in with the progress meter just to add sex appeal. It's pretty basic. You'll notice each time this refreshes, you get sort of a gray glass, and if it took long enough, you'd see the Tableau spinner as well. Some people object to that. You know, they would much rather have something that looks almost more dynamic, and if the data underneath was moving, it would almost seem to be an animated experience. We can do that too. It takes a little bit more work. You essentially are sort of double buffering your renders. So I'll show you the way that works. This is going to render a slightly more complex viz. And what essentially is going to happen, and let me select my date and time, there's a hidden div. One in front, one in back. We're using a Z index. And if you watch the date and time, that's actually the only thing that is going to change. When we refresh, we're simply bringing the hidden div in back to the front and the one that was in front to the back. There we go. We just refreshed. And then we'll go through that process again. So essentially, halfway through this refresh cycle, the hidden div actually begins refreshing. And then when we're all done, it comes to the front. I'm going to go ahead and just kind of let this finish one more time, and then we'll jump into the code on this one as well. There we go. So again, if the data under the covers was constantly changing, we would see something that looks pretty much like a viz that is being modified. Let me get the right file here. And I may need to refresh again. All right. So again, I even put the JavaScript inline here. This is just absolutely terrible for the developers in the room. I apologize. All right, so we have a refresh interval. We're just using timers, essentially, to do this. Every 22 seconds, we're going to do something interesting. Our first timer is going to call reload. And the most difficult thing that happens here is we have an if statement. We're essentially seeing which div is active. And depending on which div is active, we send one to the front and one to the back. And then we also tell our little timer, or excuse me, our little progress meter that it needs to reset. So that's it. Timer number one does that. We have a second timer, which I'll show you as well, which is responsible for, imagine that, refreshing the non-active viz, so the one that's hidden behind the div that's in front. And this is equally simple. Essentially what this does, if I can find the method here, is it detects which is the active viz. It uses the correct variable. We have two viz variables, one for each of the viz, and we're recalling one of our methods called refresh data async. In other words, go back to the database, get more data. And we're doing that over and over and over again. We have one different little timer, one third one, and this I'm hesitant to even mention, but I'll just sort of hit it quickly. Right here, we have a third timer. Remember, we don't want to start the refresh process until the meter is about here on the hidden div. So this third timer just delays that for the first time, and then we refresh as usual. So that's kind of fancy refreshing. What else do we have for you? Okay. So this last one is kind of fun. We showed this last year. Last year, one of the really big new things, it was 8.2, was storytelling, right? Telling stories with data, really big deal. And I thought it would be kind of cool if we had a storyteller as well, sort of an avatar that would herd the user in the right way, that could act as kind of a guardian, maybe even almost a mechanism to deliver help to the user, above and beyond just letting the user kind of struggle. We sometimes need to herd them in the right way. I thought what's a very popular, well-known, or hated technology avatar, and that's what I chose to use for this. So there he is. It's Clippy. Now, Clippy actually makes noise. I'm just plugging this in. All right, he just tapped on the screen. So anyway, he's taking a look at the pie chart here. He's going to discover a problem with the adventure game segments of my game business. And he's actually going to tell me. Now, he's also using the JavaScript API to select that slice of the pie chart. So you see some fairly interesting integration here. He's just told me to essentially find a city selling adventure games and click on it to do further investigation. Now, how many users are in the room versus developers? Okay, so we can't talk about you. So let's say I just happen to click on the wrong thing, like Panama City. This is not one of the places I'm supposed to go. Well, Clippy will detect that, and he doesn't like that. He's saying, hey, you clicked on the wrong thing. I told you to do A, you did B, why don't you try again? So here's how we're going to be able to deliver sort of a guided analytics experience. We're watching what the user is doing, and when they do something that we don't want them to do, we put them back on square one and say try again. So I'm going to go ahead now and click on one of these cities that is a correct city, and we will get another one of our friends. He's my second favorite. There he goes. There's Merlin. He's a good guy. Now, Merlin is going to cast a spell which uses the JavaScript API to give us a different dashboard. And then he's going to fly around, and since we're a Seattle-based company, he is going to select the state of Washington, which will actually filter the rest of the visualization. And then the rest of it is him just telling us how wonderful we are and doing all that sorts of stuff. So this example is, dreadfully silly, right? But it gives you an idea of how you can tie different things together. So let me get in here, and we will show you how it was done, mostly by copying and pasting, as I said before. So, okay, that's sort of interesting. Every time I do this, it's being difficult. Very good. So, where did I find this? The add-in itself is just another free jQuery add-in. And so people wonder, where do you find these things? I spend way too much time on the internet, and essentially at the end of every month or so, I Google cool jQuery add-ins and this month. And I will typically find 7 or 8 things that are cool, and out of those, maybe 1 or 2 of them might be something that I can integrate with Tableau. So I just kind of keep my eyes open. The way this actually works, we're going to render the viz in the exact same way that we did before, right? We're pointing at a div. Now, where does the workbook live on Tableau server, width, height, etc. The only thing that's new is right here. When the viz is initially rendered and first becomes interactive and usable, we're going to fire a method called, or a function rather, called initClippy. And initClippy is just using the jQuery add-in. We show him, we move him around, we have him speak, We play actions like looking right and getting our attention by tapping on the screen and doing all that stuff. Now here's another action where he gestures up at the pie chart, and we have a callback function, right? So at the same time, after 5,000 milliseconds, we call select pie. And here's a little bit more Tableau JavaScript API. I get a reference to the embedded visualization inside that dashboard. This is a worksheet in the workbook called pie. So we go into the dashboard, which is a sheet itself. We get a worksheet that is a part of the larger dashboard. It happens to be called pie. And then we say, okay, I want you to select a specific mark. It's the mark for adventure games. It's the genre of game that we're dealing with. And then we're adding a little event listener as well to wait for a user to do something. Essentially click somewhere in that dashboard. When they click, we are going to get pairs back, sort of key value pairs representing what was selected. We are going to see if they selected adventure games. If they don't select adventure games, that's where Clippy got a little bit ornery, right? He scratched his head. He said, you chose the wrong city. He actually told us the city that was selected, which was sort of interesting. So again, we're kind of reading what came back from Tableau and making that part of our workflow. We then do the same thing that we did before. We grab that pie chart again, we select adventure games, and we move along. When Merlin comes into play, exact same sort of stuff. He speaks. Here we are actually giving a value of the key value pair that was selected. He's surprised, he's thinking. This is when he cast his spell with another callback function. Here we're just doing something that's anonymous. We're saying, okay, grab the sheet or activate the sheet asynchronously, and I want it to be the sales dashboard. That's how we switched it. He does his various stuff. And here again is where he actually switches to Seattle. He gets a specific worksheet in the dashboard. In this case, it was named Map. And then he switches us over to Washington State. And that's it. So again, you can see some really ugly code, as Tomas would say, doing some interesting stuff. So at this point, I'm going to go ahead and hand off back to Michael. And he's going to show you some more impressive stuff.
Thank you, Russell. So there's a saying that if you're not very good at coding, you should become a pre-sales consultant. And if you're really not good at coding, you should become a manager of pre-sales consultants. So amazing that you were able to achieve all that, Russell. Good job. So a lot of what Russell showed you is the main components of the JavaScript API. You can load dashboards. You can switch from sheet to sheet. You can filter and select marks, things that the users can do. And these are typically used in portal type of situations or integration type of situations. But one of my favorite things to do with the JavaScript API is to look into types of actions, types of interactions with dashboards that you currently can't do with the dashboard. But the flexibility of being able to code a bunch of different things together gives you the ability to do some of those things. I'll show you what I mean. Here's an example of an embedded dashboard. And as you can see, there's no other HTML elements on this web page besides the dashboard. And it's a pretty simple dashboard, actually. Now, I've actually had this question on sales calls. All right, I have my date range slider. I'm showing about 4 years or so worth of data. At that level, I don't want to see the individual days or even the individual weeks, because that would just be too messy of a line chart. So I want to show, when we're looking at that amount, that large of a range, to just show it by year. But when the user decides to filter to less than a year, reload the dashboard. The user decides to filter to less than a year or so. We switch to showing you quarters. Change the granularity of the data. And if we go even further and show about a month or less than a quarter, maybe a couple months, we switch to showing you by month. And finally, if we go all the way less than a month, we're going to show you all the individual days. So I think that's a pretty useful thing, useful type of interaction that you simply cannot do with dashboards today. So how do we do it? Well, it falls under a category of JavaScript API tricks that I call hidden parameter tricks. And since I invented that subset of tricks, I got to name it. So I'll show you how I did that. Here's the code. As you can tell, it's pretty simple. Now, Russell had a few of these event listeners. Do something when the user clicks on a mark or changes the filter or changes sheets. Do something. So add an event listener. Anytime the user, zoom in there. Anytime the user changes the filter, in this case there's only one, kick off a process of JavaScript. All right? And then we need to find out, we have to get that filter. So first we get the field name of the filter. Make sure it's the one we're talking about. They didn't change some other filter. In this case, it's the only one. But we want to make sure they're changing the filter we're thinking about. Then we get the filter, and then we do something with that filter. This is an example of some of the asynchronous programming that goes on with the JavaScript API. I'm not going to talk too much about that, but a lot of what you do is do this, then this with the JavaScript API. Now we want to get information from that filter. We want to check the max date and the min date. That's simply by doing filter.getMax and filter.getMin. Then we do some math, check the difference in dates. If the difference in days is greater than 2 years, then here's some more JavaScript API. You can change a parameter. And this parameter, you didn't see any parameters on the dashboard. But parameters are really flexible. They can change a single dimension or a single measure to do different things. So they can show you different sheets. They're very flexible on what you can do with a parameter. The only downside is that you have to be showing that parameter to use it, and that's the only way to use it. What we do here is we create that parameter. We define our date dimension based on the selection of that parameter, and then we hide it again, stop showing it. Despite the fact that we hide it, we can still affect it with the JavaScript API. So if we're showing greater than 2 years, we change the parameter. Which parameter is it? It's called choose-a-date field. We'll change it to the value year, and that changes so that we're showing 1 dot per year. If it's less than, 3 quarters, if it's less than 2 years but greater than 3 quarters, then we change it to quarter. Less than that but greater than 3 months, change it to month. Less than that, change it to a day. That's it. Changing a parameter, but it's hidden. Now the next example of a type of interaction that I've wanted to do in the past, but is not built into Tableau dashboards, is what I call a filter sizing, or an action sizing. And it falls into another subset of these hidden parameter tricks, which are driven by user clicking. So kind of event listener parameter tricks. Again, I get to name it. I don't care if you don't like that name. All right. So, again, here's a dashboard. No other elements on this web page besides the dashboard. And it's a pretty simple one. We have our list of states up at top in a bar chart. And then we have a scatter plot of all of our states. Once you get to a scatter plot of this size, a typical highlight action, right? I might see Illinois, for example, and want to see how that compares to similar states on the scatter plot. In Tableau, you can create a highlight action, which will highlight those. But because the number of states we have on this scatter plot, it might be hard to find, especially when you got into this bottom left-hand range. The highlight action wouldn't make it pop out enough. So instead, using the JavaScript API, I see something like, Illinois is fine. Reload the dashboard again, of course. See something like Illinois, click on it, changes colors, and grows in size. I can clearly see where it is on the scatter plot. Try that again, click on Virginia. There's where Virginia falls on the scatter plot. So how did we do this? As I said, it combines event listeners and with the hidden parameter that trick you saw earlier. Actually, let me show you kind of how it looks in desktop too, because that's a key component. Here's that scatter plot you see, and we have this parameter here. What is the chosen state? So if I choose Mississippi, for example, it gets larger. And this is all built into Tableau, the ability to change a parameter and size things and color things. Requires calculation. Let's find that calculation. What's it called? Color. Oh, it's going to be aggregated. Here's color. It's simply a Boolean checking if the state, and it's an aggregated level, so I did min, if the state equals the parameter. If it is, then we give it a different color than the rest. Similar thing with size. We'll increase the size if it's the chosen state. Otherwise, it's just a normal number. So what do we do with that parameter? Again, we create that parameter, hook it all up to the calculations, then we hide it. Now here again, you see that we're loading the dashboard. Again, we're creating an event listener. In this case, it's a mark selection event listener when the user clicks on something. And so that means whenever a user clicks on a mark. And that would be similar to an action filter or action highlight action. When the user clicks on a mark, we want to we grab the event. From that event, we grab all of the marks that they clicked on. Save those in a variable called marks. We double check. This is a key thing if you use marks selection event listeners. You have to check that it's greater than 0. If you deselect, that'll kick off this event listener. And so you want to check if the marks.length, the number of marks, is greater than 0. If it is, we will grab the sheet name, get worksheet.getName, that they clicked on. If they clicked on the scatter plot, we don't want to do anything. If they've clicked on the bar chart, we do want to do something. So we check that they clicked on the name of the bar chart, which is sales by state. If they did, then we call marks sub-0, the first mark. Might need to loop through. In this case, I just did the first one. Get the pairs, key value pairs of all of the different values of the marks. Dot get state. What state did they click on? Now we have what state they clicked on. We want to plug that into the parameter. So again, we call change parameter value async. Which parameter are we changing? The chosen state. And we pass in that variable state that we just got. They click on Texas. Which mark did they click on? They clicked on Texas. Let's change the parameter to change it to Texas. Now all those calculations change based on that, and Texas will get bigger. Also, this else statement would be fired if the marks.length is 0, which means they deselected, and then we want to change the chosen state to none. All right. So that's it for hidden parameter tricks. This last thing is something people occasionally ask of us, which is, can you do kind of a collaborative viz? So we used Socket.io, JavaScript API to do that. So I'm going to log into Tab Chat here, what I call Tab Chat. I log in, and I see a viz. And looks like Russell just joined. Thanks, Russell. So Russell's in there chatting along with us. What you don't see is him on his laptop. He sees this exact same viz. And now what a user can do here is we can obviously chat here in the chat window. But it's not just a viz next to a chat window. Thanks, Ape, whoever Ape is. And I can grab my lasso and start to select some marks here. Let me zoom out just one. As you see, it says Mike selected 132 marks on the map. Welcome, Andy, as well. Russell clicked on those. Now, Russell, if you will, on his machine, select some other marks on either sheet. So, as you can see, my hand was not touching anything while we did that. Russell selected 26 marks on sales over time. And Russell might say in the chat window something like, check out these profitable marks or something like that. And he says, our days are numbered. All right, I better click on it before it flows to the top of the chat window. 26 marks. I click on that. And as you can see, I've selected the marks that Russell selected. So we can collaboratively point out different marks. Andy selected some marks too. Let's see what marks Andy selected on. Where's Andy? Raise your hand. You're in trouble. Thanks, Andy. Those are the marks he selected. Similarly, we can change genres. Russell, there he already did it. And he's checking out a couple of the genres, and we can click on genre, and I can see he basically deselected adventure games. So he's taking that out of an analysis. And we can do analysis together on this viz from afar. All right, John, just in time for the end of the party, sorry. All right. So how do we do that? Oh, actually, I have some information in here. Okay, in case you're curious, TabChat is built on top of Socket.io, which is a module for Node.js, and it allows this kind of two-way communication with the server. That's neither here nor there, but I'll show you exactly what it does in this case. So any type of chat would have this kind of server-client architecture. You know, Andy, me, Russell, all of us are logged in as clients to this central server application. And when client D says something or selects marks, that message is sent to the server. Hey, I selected some marks. The server then turns around and tells that to all of the other people. In this case, it also sends the collection of marks to those other people. So that's pretty much all you need to know about the... oops, I need to escape out and then switch. That's all you really need to know about at a high level how it works. But let's look at how those different interactions work inside of the actual JavaScript API. So here's the client-side JavaScript file. Every one of the users got this file in their browser, and now the browser is running this JavaScript file. And we load the viz as normal. You've seen a few examples of us loading, every example loaded the viz. You've seen a few examples of us creating event listeners. So when the user selects marks, that kicks off a process, just as you saw earlier. We take that event, we get the marks. If they actually selected something, you saw that earlier, then we do stuff. We grab the name of the sheet with getWorksheet.getName. And then this is the key way we send the message to the server that this happened. Socket.emit client marks. So we're just telling the server the client selected some marks. And we can pass a payload in this function. In this case, it's the name of the sheet and most importantly, that array of marks that we got. Similarly, we add an event listener for filter change. Does the same thing. If that user change the filter, grab the genres array, send it back to server. Now, what does the server do? This is the server-side JavaScript, right? A central application running somewhere, and it's running some JavaScript as well. In this case, it's Node.js. And it's listening for different messages. It's listening if the user sent just a text message. If the user sent a text message, then it turns around and it emits that message to all of the sockets, that is, to all of the different clients. And it says, who sent it? Oh, not that one. Who sent it? And what they said, the data. If it's client marks, that is, if the user had selected marks and that went to the server, we would say Russell selected, or sorry, we're not actually writing the text here yet. We take the name of the user, Russell in this case, the marks they selected, and which sheet they selected. And we send that to all of the different clients. What do we do when the user filters? Same thing. Who sent it and what did they filter to? Now those messages go out to all the clients. Now what happens? We have to display that information. Again, we're listening for if they send a message, we'll just add that message. If we got in a message that someone else received marks, then we need to do some JavaScript API stuff. We loop through the marks and turn them into Tableau marks. We create a message, Russell selected 22, 22, how many marks are there, on sales over time. You also notice that this is some HTML here. So that's why there was a little link inside of the message, something for the user to click on. And when they do click on that, it calls the select marks function. That's the last moving piece here, which is what happens when the actual user selected marks. Well, once again, we call viz.getWorkbook.getActiveSheet.getWorksheets.get, and then the name of the sheet that Russell selected. And then we'll say, for that sheet, select marks, async. That's the JavaScript API function. And we will select all of the marks that Russell selected. And that's pretty much it. A user does something. That's sent to the server with all of the information. Then we take that information, send it to all the other clients. When they want to actually see what the other person was doing, they click a mark. Calls the JavaScript API to filter or to change marks. So that's all I got for you today. Next up is Tomas, Zen Master / hacker extraordinaire. Go for it.
Hey, welcome all the Jedis and Russell. So today I'd like to show two examples what we are doing when we are not doing some project work for consultants. And to make it more fun, I prepared my examples in ClojureScript, which is a different programming language than JavaScript, but it can compile and generate JavaScript as well. The reason why we are using ClojureScript is because it's very, very trendy. Actually, I'm from Europe, and we Europeans are a little bit snob, and we'd like to do things differently. That's number one. Number two is that this really saves us from the guys who are, noobs, starting to write code in JavaScript with copy-paste, if you know what I mean. And So that's it, which means that when I will show some code to you, this will be a little bit strange for you. Actually, it's a Lisp. The programming language was invented 60 years ago, so it's strange. Okay, so let's get started. What do we have? First question, do you remember the old Nokia phones snake game? I do. And I spent a lot of time, especially on the toilet, to master this game. And I still believe that this game is, even it's not the best game on this planet, but it's in the top 10. So I just wanted to check how can we use the JavaScript API to build this fancy application inside Tableau. So let's see if it can run inside Tableau. Obviously it can, because otherwise I would not put in the name into the slide. So let's see how does it work actually. So this is it. Refresh it. Full screen. So I can control it. As you see, this is a regular Tableau dashboard. I mean regular. We have pills, what our snake should eat, and these pills are actual marks in a scatter plot. And if I eat one, actually I have nitro also in the game, so if I push the space, it's way faster. So I can try to eat these scatter plot pills, and my score is just increasing, and when I die, everything dies once. I can see the top scores from the other players, and just for the curiosity, so Jeffrey Schaefer is one of the other Zen masters, and if you check, he spends, I don't know, 20 minutes at least per one game. And another guy there is Date Remix. This is he's the one who owns the Tableau Public. So it's and the common between these two guys that both of them are teaching in universities. So it's not really a coincidence. Now, let's check how can we write such games in Tableau. So first of all, let's start with the workbook. So no surprises. We have one scatter plot, and all these marks are having a unique identifier. That's what I call location. And in the JavaScript, with the JavaScript API, we just control by selecting the filters which pill needs to be rendered where. So if I filter, let's say, for only a few pills, I can see all of them on the gaming area. So that's if I change this filter, then it will change inside. The other one is also a little bit. I mean, why it's a little bit different than the others is because in this visualization, which shows your top score, it doesn't use any data source at all. So everything is coming from parameters. That's why I can show your real-time live score after the game from Tableau Public. So there are no data sources behind, and it's still interactive, and it's still real-time. So every bar on this whiz has its own parameter, and I just need to change it after the game ends. So let's see the API part. So this is how you can add the visualization into the HTML part. So that's actually the JavaScript code. You can define your URL. You can select the div ID, which is the game, add the viz options, and render the object. What is also different from the JavaScript world, that we usually don't call these embedded Clojure functions. We use asynchronous messaging. So the game part listens for messages from the Tableau module, and if the Tableau module is ready with rendering, it will just send a message to that other piece, and it will know that it can start the game and rendering the cursor. On the other side, we have another Go loop. If you're familiar with the Go language, then it's the same concept. So if the game engine, which is also written in ClojureScript, sends an event that we eat a pill or died, it will change the filters accordingly using this apply filter async function. Okay, let's see something more advanced. I mean, the snake was just the beginning, but I mean, all of us like to do something more social, like the chat program, where we can play against each other. And as we are in Vegas, I prepared something more Vegas-ish, is there any word for that, which is actually a blackjack game. And to make it more fun, it's a multiplayer blackjack game. So let's see how it works and how can you build something like that. And to make it more fun, because I like fun things, don't use browsers. Let's use a Tableau desktop. Because Tableau desktop also has a new feature called the Web Data Connector, and Web Data Connector is a browser. So why don't we render the whole stuff from the Tableau desktop? It's possible, I guess. So let's select a new data source. Let's select a Web Data Connector. And let's open my application. I'm Tomasz, that's my name. Let's take the time. Player 1. Let's start a new game. All right, so I have 17 points, and the dealer has a card with 10. I can stand here and see what happens. I lost. But as I told you, this is a multiplayer game, so let's see what happens if another guy joins to the same party. Let's start another desktop, because I love this product. So if I can find it, yes, I do. Let's connect to my data source, more servers, Web Data Connector, and open the same game. And I will use my brilliantly creative mind to select another username, which will be Tomasz2. And start a new game. And both Tomasz lost. Okay, let's start another one, because it's, well, he had a blackjack. So as you see, both windows, which are totally unconnected, are having the same dealer cards. I can see the other player's score on the top, so they are connected to each other. And if I hit another card, it will update not just my visualization, but it will also update the other one, so it will be fully, I mean, all these two desktops are fully connected. I can stand here, which will tell the other guy, no, so it will tell me that I have to wait for the other player, and if the other player stands, it will show the results. And last thing, I mean, and I won, which is great. So let's show something else. So here, if I log on this machine as well, I will see the same game as player 1. So if I hit another card in this desktop and I'm player 1 there as well, then the two visualization, because I'm using the same username, will be also synchronized and updated together. So that's how it works, and let's see how can we build this kind of things. And so in the previous example, I used a way like messaging that the game we will send messages to the game engines. Here I'm using another way. It's called Atoms. It's so advanced that I'm not even going to the details. But the thing is that when our Tableau dashboard is loaded, we will start a Socket.io-like WebSocket server in the background. We will do user authentication, like handling, setting the usernames. And just like for what Realk does, we send always the direct clicking information to our Socket server, to the central gaming server, and the gaming server will send back always all the information from the game, including my player, other player, and based on that information, it renders the Tableau itself. Let me just show quickly the workbook itself. It works in a pretty similar way as the previous one. So we have let me show the filters. So we have the cards here with the position, and if I change this from 52, which is an empty card, to 51, I will see the king, and that's how I can, with using filters, that's how I can put the different cards on the visualization. And this is also like a normal scatter plot with shapes, and I'm using custom shapes for the individual cards. I think it's fancy. So why it's important to learn things with games, and why do we play with this stuff at all? I mean, for first look, it makes absolutely no sense. The reason is because the same concepts can be used for push notification. This is something what our clients usually requires. If there's something changed on the dashboard, we can just pop up a small window on the bottom. We can do real-time monitoring, refreshing the data if it changes. So we can have some agents on the server side and don't poll on the refreshing. If something changed on the back end, we just send a message to the client, and the client will do the refresh. So it's much smarter than a regular update. We have also persistent sessions, just like in TabChat. So two different users can see the same stuff in multiple windows. It's a co-op reporting flow. And also we can have multi-device synchronization. So what I see on the desktop, I can have exactly the same selections and the same stuff on my mobile devices. So we usually build this kind of solutions for our customers. That's the second time that I kick this lamp. Okay, I think that's the sign. I think that was it.
Thanks, Tomas. And apologize to everyone that we didn't really leave too much time for Q&A. We might hang around out here while the next group comes in here to present, and you can come talk to Tomas and myself. You probably know the drill on this already, survey. A couple other useful things, especially if you want to ask questions. Two good places to go. As Tomas's company, StarSchema.net, has a booth here in the expo hall. If you want to go talk to Tomas, learn about all the cool JavaScript API stuff they're doing and all of the other non-JavaScript API cool stuff they're doing, that's a good place to talk to them. We also have a developer kiosk kind of towards the center near the bar chart, which is just the bar, in the expo hall, and I'll be there today from 3 to 4:30, specifically answering questions about the JavaScript API. Web Data Connector Hackathon tonight, not related to JavaScript API, but it'll be a lot of fun. That's from 6:30 p.m. to 1 a.m. Space is limited. I don't know if we're sold out yet, but if you want to go to a hackathon, build your own web data connector stuff tonight, check out this link, tc15.tableau.com/WDC-hackathon. And there's some more developer sessions. Here are some good links to take a picture of. GitHub.com/covenor/tc15-JS API should have all of my stuff. If it's not up there today, I'll have it within the next week. Developer.tableau.com is a new one-stop shop for all API-related resources. And StarSchema.net is Tomas's company to see all the cool stuff they're doing. And no questions.